now let's work on graphing some bivariate inequalities. So here's something I sent you guys before. Here we see something that is like in standard form. So what I would do, hmm, well, immediately I might simplify this, divide everything by 2, because this isn't actually standard form, right? Because it should be simplified. So you have 4x minus y is less than or equal to -6. Actually, it might be easier to just plug something in here to see if it's true. So if we have -2, so that'd be 4 times -2 minus 4. That's -8 minus 4. Yes, that is the solution. I already know. I don't even have to calculate it. I know it's less than that. Okay, then we'd have 4 times -3 minus -6. Is that less than -6 or equal to? That's -12 plus 6 is less than or equal to -6. That's -6 is less than or equal to -6. It's on the boundary, but it can be included. So yes, that is also. Now this one, 4, this would be, I can change colors again. Using this thing at the top, 4 times 1 minus -5 is less than or equal to -6. No, that's 9, right? 9 is not less than or equal to -6. And then 0 here, 7 is a yes, because that's -7 is less than or equal to 6. So simplify it a little bit. I don't think putting it in slope intercept form would make it that much easier. You'd still have to like substitute it in this whole time. Oh, this is kind of fun. So it's just like which of the x, so you can ignore all the y's, which of the x's are more than or equal to 3? No, no, yes, yes. Bang. Okay. Same thing, look at the y. Which of the y's are greater than 0? Yes, no. This one can plug in, get stuff like this. I'll do another one. I was going to say I was going to pause the video. You could divide this all by 4, make this easier, but instead of just pausing the video, just go do this yourself. Boom, in the review. Um, where was that? Yeah, 80% of kids have done this. So it's available there for you to practice. Okay, now let's try one in slope intercept form. Okay, so how do we do this? Well, it's basically you graph the line, test the point, shade. So let's just pretend it's y equals -5x minus 2. Go to -2, go down 5, 1, 2, 3, 4, 5 over 1, or go up 5, 1, 2, 3, 4, 5 over 1. Okay, cool. I have this line. And now I can see it doesn't equal it. So when I draw this line, it's actually going to be dashed. So I can't easily erase on here. So I guess I'll just go like, it's going to be a dotted line. Then I suggest testing the origin to see if that's a point. So if I put in 0, 0 here, be 0 is less than -5 times 0 minus 2. Is 0, sorry, it's greater than -2. Yes, it is. Therefore, it's going to be over here because 0 is shaded, and so would everything on this side. So we solve it, bang, got it. All right, now let's try one using that tools and Alex. Okay, so I'm going to go to the y-intercept. Then I'm going to follow the slope down 2 over 3. Okay. Now I want to change this to be a dashed line because it cannot equal it. And I want to shade things that are above. So up here. Check that. Bang. Correct. Let's try another one. Actually, no. Let's go to 3. That's my first point. Follow the slope. Up 1 over 2. Got it. We do have to change it to be dashed because it cannot equal this. And I want, again, the stuff that is above the line. You check. I am on a hot streak. Okay. Now, -5. bang, the slope is -2, so that's down 2 over 1 or up 2. Okay. Now, in this case, do I need to change it to a dashed line? No, because it can equal it. And I want to know the things that are above. So I plugged in this 0, 0 here. It should work. 0 is greater than -5. It is. Bangarang. Correct again. Okay, now let's look at. Ooh, interesting. Okay. This. Okay, this is like it's almost in standard form. I just want one without a negative x value. Great, there we go. Okay, so for this, when we have something in standard form, just find the intercepts. So instead of changing to slope-intercept form, just think of it. Y-intercept is what is y? It's when x equals 0. So that's going to be y is greater than 4. So it is going to be 4. Or 0, comma 4 is our y-intercept. Our x-intercept is what is x when y equals 0. Make the y 0. That's going to be x, or 2x is greater than 4. That's going to be x is greater than 2. And that will be 2, comma 0. So I had x when y is greater than 4. So it's going to be up above this when x is greater than 2. It's going to be up above this. So when I have this line drawn, it's going to be a dashed line. And it's going to shade above this. So we said the y-intercept when x is 0, y is 4. 2, dashed line, and we want the stuff above. We check, we eat those w's. Okay, Alex, standard form should not have a negative a value. Again, my guy. Okay. Ooh, this is interesting because like the y-intercepts wouldn't be that good. So this might not be a great one to plot. I can definitely know the y-intercept. So when x is 0, I mean -4. Y-intercept is -4. Okay. Now, doing a little math, get x to the other side, divide by 2. It's up 5 over 2. 1, 2, 3, 4, 5 over 2. I'm just going to see if I can do this. It's going to be less than. All right, risking it. Oh, I am that guy. So basically what I did, just I wanted to grab the slope from this, right? So I thought I need to get x to the other side. Ooh, so I need to subtract 5x. So -2y is greater than -5x plus 8. This doesn't really matter, right? Because I already know the y-intercept. But then when I divide by -2, that is going to make the slope 5/2 x, and you flip the sign less than or equal to 5/2, and it would be -4. Yep, so I do that. So now it's your turn. I want to see how this goes. How many kids have done it? Oh, good, good. About a third of the class. Is this a two variable inequality? No, just one variable. Okay. So I think that's a good one to practice. Check in your book for some inequalities word problems to practice. All right. Lock in.